Good afternoon. My name is Mubeen, and I'll be happy to talk about latest trends to watch out for in embedded systems in 2025. So, brief about me. I'm a computer science graduate. I work at Emertxe as a technology head. It's been almost 15 years I'm working with Emertxe, which is an edtech organization specialized in the giving trainings to several audiences, including engineers who pass out of college, as well as professionals who are interested to upskill in the area of embedded systems, IoT, and full stack web application development. So prior to that, I had tenure working in companies like HP. At HP, I was one of the lead engineers to develop HP Linux print, scan, fax device drivers, which is called as HP LIP. And before that, I was working in a team called as HP OM, HP Output Management, when we used to create a product which was used for print automation in a secure way. And before working in HP, I also had the opportunity to work in Novell. You might have heard about this company, which was well known for an operating system called as Novell NetWare. So at Novell, I was fortunate to work in open source projects, primarily in their groupware suite, as well as helping manage the build ecosystem for SUSE Linux. So back then, maybe 15 years back, we didn't have the concept of Docker, Kubernetes, or systems. We used to have something called as jails, wherein we used to manage the build in a control environment. So that's a brief about me, and I work at Emertxe, which is an edtech. Primarily, we deal into trainings. So I'm fortunate to present you some of the latest trends in the area of embedded systems, which you can look out for. All right. So about the talk, it's about how things are evolving in embedded systems and AI in this year and the coming future. So any guesses? I think you all are familiar with what is happening in the near future and what is going to make an impact in embedded systems. What do you think is the most important thing to watch out for? AI? Okay, right. So that's true, right? AI revolution is everywhere. It's not just something which is looked upon in application areas, right? We all use AI as a consumer in the form of ChatGPT as well as other AI tools. And as developers, I'm sure, right, if you're a developer, we'll be looking up for more AI-based platforms which help you to basically leverage the software development in embedded systems and other areas, right? So here, primarily when you talk about AI revolution, it's not about something which you use on a day-to-day basis, right? AI is not just a tool, but it's also a foundation which is going to become a core technology used with embedded systems, right? So we're not going to use AI just as a consumer for learning things, maybe for preparing a presentation or just responding to emails and so on, but AI is going to be a mainstream in embedded systems, right? So integration of AI is becoming more and more common in embedded system because of the advancement in processor technologies, right? So maybe a few years down the line, if you see, we are focusing on how we can develop more complex MCUs, wherein it can fit in more sensors, more peripherals into it, so that we can see how we can miniaturize things and how we can develop applications which are non-AI based, right? Now things have progressed a lot now, right? As you can see here, we are have companies who manufacture different MPUs, MCUs, and we have bigger companies who fortunately were able to tint a lot of money because of GPUs and the marriage with AI, right? Now we are going a next level wherein manufacturers and design houses are focusing on NPUs, right? So all of you might have heard about it, neural processing units. So this integration is enabling more smarter and capable devices across various sectors. Now, just to talk about a specific, right, area or domain, which is healthcare. We all use wearable devices, right? And as all of us are like busy with our day-to-day schedules, often we tend to like ignore our health, right? So recently I happened to like visit a hospital wherein I had to go for a medical checkup, right? So there like I was told to like I need to meet a cardiologist just to monitor your heart parameters, right? So one of my ECGs showed some anomaly in the heart rhythm. So they said, okay, if we need to diagnose. So how do you diagnose? Right? So one option is you get hospitalized, stay there for a few days, and the hospital staff will monitor you how your basically heart rhythm is. So those days are gone now, right? Wherein we don't have to spend a lot of time and money in diagnosing what's happening, right? So we have those devices which are good enough. You might have heard about a device like Otter, which you can fit in on your chest. It's going to monitor your heart rate and performance by capturing all the information and further analyzing the data using AI. So that's how things are evolving in the medical field. So this is just one of thing. In medical domain, there are other basically devices also which are all becoming AI enabled, right? So one of the companies which recently I came across was a glucose manufacturing company. They say that they create like millions of devices to monitor the glucose parameters. And all these devices are AI enabled. And not just that, right? It's not just about getting the parameters, it's about basically deciding what other features need to be added to the software. They're also able to predict using these parameters which are shared back to the organization, right? Now, what are the challenges you're going to face? Let's say you want to develop something like a smart wearable device. What do you think is there are many challenges, right? Can you share some of those challenges with somebody who's going to design a smart wearable device? What could be the major challenges you'll come across in general you're going to develop something like a smart wearable device? What do you think? What are some of the challenges or parameters you have to look into? Size, right? So one important factor is size, right? So what do you think will be a typical speed of a processor running on such a device? Any guesses? It can vary, right? So if your requirement is not so high, wherein you just want to use something like a Fitbit, maybe you can run something like a processor which is having a speed of 200 megahertz, right? But as your requirements or feature and functionality increases, you may have to basically go for more basically speed for the processor, right? We may have to use something like 500 megahertz, right? So apart from that, what do you think is the other parameter which you have to look into? Power, right? So power is one very important factor. Now, can you guess how long these type of devices run, smartwatches run? How many days do they run? Less than a week, right? Typically less than a week if they are basically having rich features. Now, I have a son, he's wearing a Casio watch, which is a digital watch, right? My brother gifted him, right? It has some minimal functionality where it can show the time, right? You can use it for setting an alarm. There is a world clock on top of it. Can you guess what's the battery life of that? Anybody? They are guaranteeing 10 years. How many years? They are guaranteeing it. 10 years you can use that watch without changing the battery. Now, yes, it all depends upon what you want to do with the device, right? Now, maybe in this device you don't have those functionality which is enabled to monitor your health, right? It's going to give you data about your health, right? It's not able to basically tell you about how you are basically maintaining a regular health running pattern, right? Nevertheless, it's about what humans need, right? So you may want to have a watch wherein you want to run it forever, or you may want to use it so that you can constantly see how you're performing and maintain your fitness in life, right? Now, with the advent of AI, one very important thing in these devices are how do you basically ensure that they become smart with limited connectivity, isn't it? So you have a watch. One option is you need to be always connected to the internet. So when you're always connected to the internet, what is that we're going to miss? Or what is going to lose? Power, right? Battery, right? Think of a scenario wherein, yes, you don't have internet connectivity, still you may want to diagnose some information. Is it possible? Yes, right? That's how basically things are evolving. And we have companies who are working on low power MCUs, which even does not require neural processing units. Now, many a time we think that yes, we need NPUs to run an AI-based algorithm. We don't need NPUs to run a complex AI algorithm often, right? We can still get things done with something like an MCU, but with smarter software. That's still possible. Secondly, when you talk about healthcare, right, one important use case is diagnostic imaging, right? So when you talk about, let's say, diagnostics, we have different ways you can diagnose a disease. And one of the important ways to capture diagnostic information is, let's say, using MRIs and CT scans, right? So with MRIs and CT scans, you get large amount of data, right? So data which is produced from these basically diagnostic tools are pretty huge, right? And if you want to analyze it as a human, it's going to consume a lot of time. And often it requires that you need to send this information to somebody else sitting across the globe, possibly so that you can monitor and you can also diagnose things properly, because you need specialists often, right? Now with the advent of basically AI, human basically decision making has become very easy. It's not necessary that, let's say, a radiologist is always required to analyze what is the cause of a specific disease from an MRI, right? That's how things are moving. So talking about another important trending aspect in embedded systems is smarter connectivity, right? So when I talk about connectivity as an embedded engineer or an IoT engineer, few things comes into mind. What is that? Different protocols we use, right? Bluetooth, Wi-Fi, right? We use basically Zigbee, maybe Thread, and so on, right? So that is something which is ongoing and continue to be used in many of the IoT and embedded systems. So now we basically, with the advent of 5G technology, right, things are going to take a different dimension. So all of you are using 5G maybe on your mobile phones, right? We use it for maybe downloading videos, right, for video calls and so on, right? So that is one use case. But there are many other use cases which are going to transform the way how industry runs. Now, for example, as you know, 5G enables faster, more reliable and cost-effective communication, right? IoT devices can use 5G to a larger extent, given the availability. So few such use cases which are seen in 5G is that autonomous drone delivery systems, right? So now we have like 10 minutes delivery, wherein, right, we order something from Swiggy or other delivery partners, wherein yes, you can get things within 10 minutes, right? Now future is something going to be a little different, wherein we're going to get drones delivering these items, provided basically they're meeting the regulatory guidelines. And some countries like US, like they have started slowly like doing a POC of it. Another basically area where 5G is generally used is in medical domain, wherein you want to monitor patients remotely as well as for remote consulting, right? So now Consulting, for example, requires you to have good set of resources, isn't it? Right. So you need to have a specialist doctor, depending upon the case. So one of my relatives, 2 years back, was diagnosed with cancer, and she was at stage 3 or stage 4, right? Now you want to consult a doctor who is in UK. It's not just about making a phone call and do a diagnostic, right? You should be able to see and analyze what's happening in her stomach, which was affected. So using 5G technology, the advent of 5G technology not just helps in diagnostics, and in future I believe that we'll be able to perform like assisted robotic operations using 5G as well, right? So robotic surgeons are available, you know that, right? So these robotic surgeons make use of robots to basically do the surgery. Now imagine this robotic surgeon operating from a remote place using 5G technology at real time, doing an operation, and that is going to be the future of 5G. So when you talk about 5G, one thing comes into picture is that, okay, is it going to consume a lot of power? Yes, right? At times when you use 5G, you've seen that the power consumption in your phone goes very high. When you talk about IoT devices, they have a lot of limitations. What are the limitations? They are miniature, right? They may not have enough battery capabilities, or they may not be always connected to the power, right? So when you talk about 5G, this is something which is recently evolving. There is something called as RedCap, which is a game changer. Reduce capability in 5G. So RedCap is a game changer for IoT using private 5G networks, right? Which delivers stripped back version of 5G. It's not full-fledged 5G. So smaller devices, IoT devices, which are used in industrial sensors, wearables, etc., compact devices can make use of RedCap. So benefits that make a RedCap a vital enabler is like you can use it for improvising the industrial automation. I'll show a use case wherein 5G connectivity replaced Hyundai's previous Wi-Fi setup. Right? So previously, right before 5G, they used to use something called as Wi-Fi setup. And in South Korea, they have a plant which manufactures the highest number of cars in a day. Can you guess how many cars are manufactured in one plant in a day? Rough. Hundreds. So they have 6,000 cars manufactured. 6,000 cars manufactured on a day. And they want to improve the productivity, right? So they use RedCap, and slowly, basically, it helped them make improvements in real-time data transmission, reliability, and speed. So this is something which you can look for in the near future. Similarly, it's not just about AI. IoT is also growing. Anything and everything is getting connected to the internet using IoT, right? So let's talk about smart vehicles, autonomous vehicles, right? So at least we've seen many of the cars across India getting equipped with, right, ADAS, right? And in, for example, US, when you go, you can see cars like Tesla who are like manufacturing autonomous vehicles, right? Now it's not that they are foolproof. We've seen videos wherein, right, you have autonomous vehicles which goes round and round in circles and will take you some other location because of defects in the car, right? Similarly, predictive maintenance is something which is also evolving in automotive segment, right? So AI analyzes data. So how does AI analyze data? It analyzes the data from the various sensors. For example, in your car, you may have something like a TPM sensor, right? Tire pressure monitoring sensor, simple sensor. So what does the TPM do? It monitors like what tire pressure in your car. Imagine you're going for a long drive. You don't have a tire pressure monitoring sensor. What will happen? And you're going to a remote place. So this tire pressure monitoring sensor is going to show you basic information about tire pressure. If something goes wrong, you can replace it ahead of time, right? Like that, there are several other basically AI-enabled predictive mechanisms built into a car, which will help you to take decisions before you run into trouble. So next we have security, right? Security is something which is very important. Now, so we are into like training. So often we send students and working professionals to companies for like hiring requirements. So one of the companies was LG. They are hiring for cyber security. So in the interview, they're asking questions on how do you hack a car, right? How do you hack a car? Is it possible? Let's say I have a car. Can you hack it? Yes, it's possible, right? So why is it possible, by the way? Why do you think a car can be hacked? Huh? It's connected, right? It's enabled with IoT. Anything which has connection connected to the external world, maybe to a server, you can have mechanisms to basically hack it. So in fact, a car is nothing but a system which contains multiple computers which are interconnected to each other. Imagine you're able to get access to it. You can control a car remotely. And this is nothing new. As early as 2015, people have started hacking about cars. So security is a major concern. So when you talk about security, right? So rising cyber threats and regulatory needs is something which you can look up to. Similarly, protecting embedded systems against malicious actors require more than security. It's not just about security. When you talk about security, let's say you're a web developer, what comes into mind when you talk about security, right? You need to have a HTTPS connection, data should be encrypted, and so on. So in case of embedded systems, designers and engineers must bake security directly into the embedded hardware, not just the software, right? So when you talk about technologies such as secure boot, I'm sure you might have heard about secure boot already, right? Cryptographic processing, right? There are chips which enable that. There's something called as HSVs, which enable that. Attestation is important. For example, you're having a software. Now, how do you validate that software has not been compromised, right? So you need to use attestation. For example, you need to have a hardware signature as well as software signature, wherein you should be able to remotely check whether the software has been compromised or not. Security must also be part of software development and lifecycle management. Security is not given enough importance, but it is something which we need to look into for developing IoT-based systems. So what are some of the evolving security practices? So one of the evolving security practices is adaptation of SBOMs, right? So when you talk about BOMs, bill of materials, when you talk about hardware, this is something which comes into picture, right? But what about SBOMs? Can you have something like software bill of materials? Yes. This has become a de facto basically practice nowadays, to have something called as software bill of materials and audit, so that you know which software you're using in your application, right? So you need to know. For most of the times what happens is that you end up using open source software to build your own software, and use different open source software. You should know which version of software you're using. Is it affected by any vulnerability or not, right? So you might have heard about CVs and things like that. Similarly, implementation of secure firmware updates, right? OTA or their updates are very important. So, right, you might have heard about basically scenarios wherein a car is recalled because of some bug, right? So they'll send a message telling that, yeah, something is wrong in your car and you need to call back. So I own a car, it's a Mahindra car. I also basically sometimes get a call from them telling that, okay, there is some defect in this part, we'll do free of cost replacement. Imagine you get a security bug. So Mercedes-Benz, few years back, recalled around 1.5 million cars, and they had to flash the software manually. So imagine the amount of basically human resources required to basically update the software because of a security bug. Now Tesla is something different, right? So you can just sit at your home, plug in your battery, and the software gets updated remotely, unattended. Right. So widespread use of automated security testing is also an important basically area we look into. So finally, adaptation of open source software plays a key role due to increased transparency. When you talk about proprietary software, only the company knows what goes inside, right? Whereas when you talk about open source software, it's transparent. and vulnerabilities are easily detected. Right? Community-driven approaches enhances the robustness of security defenses, right? So you know how open source works. Community-driven development happens. So next we have AI in manufacturing. So when you talk about manufacturing, one important area where AI is playing a pivotal role is predictive quality control, right? So recently I came across a company who are into laundry automation, right? So when you say laundry automation, so let's say big hotel chains are there. They have their clothes, their they want to basically ensure that their clothes are washed properly and they get it on time. Now this organization uses AI for classification of how well the cloth is washed. So you get some clothes, it will wash the clothes automatically and it will iron it and also classify that there is some defect in this particular cloth, so that you don't have to send it back to the vendor, you need to fix the defect and so on, right? So this happens because of computer vision, and factories are enabled to use AI so that they can better serve the customer. Similarly, robotics is another area wherein AI is adapted. So I just wanted to share a small video of it, right? For example, in warehouse automation, you can just see the kind of basically AI and IoT as well as embedded systems that is used so that warehouses are managed without human intervention, right? So it may look humongous, right? So without the use of AI based enabled robots, this was to be done by humans, Amazon and Flipkart would have been in loss. They will not be able to deliver something next day to your doorstep, right? So this is the future of AI. Similarly, in agriculture, we use precision farming, autonomous tractors, etc. for AI enabled devices, right? So I started with AI. So AI, when you talk about, okay. So when you talk about AI, it's most of the times we hear about something called as generative AI, LLMs, and so on, right? So whereas when you talk about embedded systems, not just about generative AI, it's also about something called as edge AI and ML. So AI in the edge is transforming how applications are designed and developed. Right? So especially in the edge devices have low constraints, right? Embedding intelligence into these devices minimizes the cloud dependency. So what is the technology impact? So technology impact is that when you use a cloud-based AI system, what's going to happen? You have a dependency on the network. The latency in which the data has to be transferred in the process is very high. Cost incurred is also very high. So with the advent of embedded AI, we have like innovative software as well as hardware, which helps like autonomous vehicles and smart appliances. So how does it work? So local data processing. It's about localized data processing, which enables the device to process data on site. Right? So you don't have to basically send the data to the cloud to process the data. For example, you might be using something like an Alexa device. Right? You take an Alexa, you need to be connected to internet. Without connecting to internet, can you use it? No. So imagine you're going to put some AI in it. Let's say you're having a smart home wherein you have a speaker which is connected to your light or fan or AC. Do you think you have to be connected to internet just to turn on the light or fan? Not necessary. It depends. It depends on the capability of the hardware, right? With minimal computing power, you can do it only with predefined set of instructions. You can say turn on light in bedroom, right? Or turn on the fan. You cannot say that I'm feeling cold. So when you say I'm feeling cold, you need natural language processing. So the device will not understand that because it doesn't have that much computing power. You need to send the data to the cloud, then process, etc. Now things have changed. Systems have become more basically intelligent so that you can understand to some extent this information as well. Right? What does it open up? Opportunities for developers, right? Developers, new venues for embedded software, developers to innovate and learn about these edge AI technologies, including things like TinyML and so on. So I have limited time. I'll have to wind up. That's what I think has been told to me. Okay, so I'll just finish with a couple of minutes. So other areas where embedded system is dominate is like trending is open source dominance. Right, all of us know that open source projects are pivotal in developing embedded software, especially softwares like Zephyr, RTOS, and Linux are in the lead. Right, so these operating systems help us to basically develop embedded systems at a very faster rate with high security and AI-based features enabled. So last but not the least, AI-propelled development is something which is important. I think this is what generative AI is all about, right? So in embedded systems also we can use generative AI to propel how the software is developed, right? The question which we typically ask is AI going to take over junior software developers, right? This question always pops up. And we can also see that Microsoft's AI employee is something which is you can look for. So what is the impact on embedded developers? Shift towards AI based development, wherein new roles are opening up. So what are the new roles? So transition from maybe a senior software engineer to a software architect is something which you can look for, as well as AI supervisors. So key considerations: balancing efficiency of AI generated code with the need of human oversight. It's not necessary that what AI generates is always 100% right, but you can always augment it with like your strong testing test integration policies, right? Quality assurance remains crucial. It's important that you don't trust AI directly. Quality assurance is important, like using CI/CD pipelines, you can automate it. And you need to have a proper adaptation strategy. Teams can adapt to a new paradigm, which AI handles the coding part of things, right? Wherein you can become a system architect to give instructions to these tools, and the AI tool will generate the code for you. Only things you need to validate whether these tools will help you. This is going to be the future of AI, right? So that's it from my side. Any questions you have? I know I don't have much of a time. Yeah, how will it affect job market is a good question, right? I think it's a very, very important question. So when you talk about a traditional embedded system software developer, you have a traditional embedded system software developer who's going to focus on your business use case, develop the software using existing tools. Now they say that in 2026, 1 in 2 devices will be AI enabled, or 1 in 2 devices will have to have AI based features imbibed in it. Now when you want to do something of that sort, we need to develop those skills so that you can leverage your skills to develop applications which have AI built into it. So what I would suggest is, if you want to plan your future, don't restrict yourself to what is traditional AI development. Try to upgrade your skills in the areas of IoT, in the areas of edge AI, and also in general learn how you can connect with cloud-based systems so that you can also use generative AI to get your work done. All right. Now, I hope I answered your question. So AI is not going to replace IoT or embedded system. It's going to be a complementary learning experience for you. You have to learn AI along with embedded systems so that you can basically propel software development in the future. And for that, you need to have necessary skills to do that. Any other questions? Yes. Sure. May I know your name? Vijay. Okay. Yes. 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 For a common man, I would say it's more of awareness. At times, what happens is that humans' adaptability may be a little slow, right? For example, nowadays you're seeing in news, right, that is something called as digital frauds happening, right? Now, with the advent of AI, you are ahead of maybe your thought process, your thinking. Things may not be the same for you in the way you see it naturally. So important thing is that you need to get educated about AI first of all. So for end user, it's all about use cases, scenarios, and so on, right? So for example, I'll give you an example which I faced recently, right? So I have a watch which is going to give me information about my heart rate, right? Now based upon that information, can you buy a medicine? No, right? So you may get information insights from these devices, but decision making is something which you should not be doing. There is a possibility that people may fall for it, right? Nowadays, by googling, using generative AI, right, you become a doctor yourself, right? Such things have to be careful about. I just gave an example. Similar things you need to be careful about. It's all about adaptability, creating awareness about how AI will help you to basically become more intelligent, I would say, by using the AI features. Okay, I think time is up. Thanks for everybody for asking questions and paying attention.